Hello everyone, and welcome to your video on circles. So we know that when you have a circle, one of the primary things that you could measure would be the radius, which is the distance from the center of the circle to the edge. This is an important variable when it comes to circles because it is used in the formula for the equation of a circle. The equation of a circle is x squared plus y squared equals r squared. So, for instance, if we had a circle and we knew that our r was 4, and then we could say that our equation must be x squared plus y squared equals 4 squared, which is x squared plus y squared equals 16. Isn't that nice and straightforward and easy? Yes, it is. Okay, it does get a little bit more complicated because if your circle is not right here where the center is the origin, then we have to move it, right? And so if we're moving our circle, let's say we want to draw a circle down here instead, then we need to adjust our equation. So the fancy equation would be x minus h quantity squared plus y minus k quantity squared equals r squared. So again, we have that h and k slipping in there, which we only need if our circle is off the center of the graph. Again, just like before, you will be happy to know that Fred has all of his circles right there where they're supposed to be on the origin. Okay, now I do want to explain to you how the circle equation is related to the ellipse equation. So remember that the ellipse equation is what? Well, it's x squared over a squared plus y squared over b squared equals 1. The circle equation is x squared plus y squared equals r squared. Okay? I tell you what, let's draw a circle so that we're not talking in the abstract. Here's our circle. And I'm going to draw an x radius and a y radius. That way, it looks just like it would if this happened to be an ellipse. And we're going to say that this distance is 5 and this distance is 5. And those have to be the same, right? Because in a circle, all radii are congruent to each other. So you have to be dealing with the same thing. So let's put this circle in an ellipse format. So that would be x squared over 5 squared plus y squared over 5 squared equals 1. And that could be rewritten as x squared over 25 plus y squared over 25 equals 1. Now in a circle, if you stick it in the ellipse formula, your denominators are always going to be the same because your a and b are always equal to each other, because the length of your radii are always the same. Okay, so in order to get from this format to this format, what we do is we get rid of the denominators. So here, I'm going to multiply this equation, or this fraction, by 25. And I'm going to do that for all of them. I'm going to do 25, and I'm going to do 25 over here. So the effect of that is that those 25s cancel out, these 25s cancel out. So we wind up with x squared, and that's all that's left, plus y squared, that's all that's left, equals 1 times 25, or 25, which is, by the way, r squared, because it's 5 squared. So my point here is just to show you that there is a relationship between this ellipse formula and this circle formula. But for, I don't know, being streamlined and efficient, when we deal with circles, we usually just jump right to this more streamlined equation rather than slogging through the ellipse equation, even though this would work. This is more streamlined. All right, that's about all there is to circles. I mean, they're pretty straightforward. So hopefully now you're ready to do all of your turn to play exercises. Good luck.